To help visualize some of the properties of light, we've set up a demonstration in which ball bearings represent photons. Of course, ball bearings are made of matter, and photons are really energy. But we can use the ball bearings to represent and help us think about some of the behavior of light. The light is actually a stream of very small packets of energy called photons, traveling very fast.
Light travels from a source of light like our sun, the stars, a light bulb, a candle flame, computer screens, fireworks, and even fireflies, directly into our eyes. But most things we see are not sources of light. We see most objects because light that originates from a light source strikes these objects and then is reflected and enters our eyes.
In this demonstration, we're using a shallow water table and a slide projector as a light source. If we shine light on this mirror, the light is reflected. As the angle of the incoming light changes, the angle of the outgoing light changes by the same amount. The angle of the incoming light is equal to the angle of the outgoing light. The light does not spread out as it reflects from the mirror. In this representation, we can follow the path of light and see that the angle of the incoming and the angle of the outgoing light are the same. All objects reflect light, so then why don't we see our reflection in this plant or in this duck? Let's go back to our water table demonstration. Light hitting the mirror is reflected without much scattering. Only one number is brightly lit. If we replace the mirror with this card, the light still reflects. However, if you look at the numbers at the side of the water table, you'll see now that several are illuminated. The light reflected from the card has spread out. When light reflects from a surface that is rough, it is scattered. But when light reflects from a mirror, it is not. The reason for this difference is that mirrors and shiny metals and glass all have very, very smooth surfaces.
But many objects seem pretty smooth. The poster, for instance, or the card we used in the demonstration appear to be smooth.
To our fingers, paper feels smooth, but to a photon, it's actually rough. Let's take a look at a piece of paper under a microscope and see. When we magnify paper, we can see the individual fibers that it is made of. With this magnification, paper doesn't look smooth at all anymore. So to a photon, paper is rough. And although a single photon will still obey the law of reflection, since the paper is not smooth, photons that hit this paper would bounce in all directions. Let's see what happens when photons hit a smooth surface and when photons hit a rough surface. When we drop ball bearings on a smooth surface, like this piece of tile, they bounce straight back up at the same angle that they hit the tile. And when we drop them on the underside of a tile, the rough side, they scatter. But the law of reflection, that the angle of the incoming light is equal to the angle of the outgoing light, still holds, as we see if we follow the arrow on the rough surface. Here it is again. When we drop ball bearings on a smooth surface, they bounce straight back at the same angle that they hit the surface. And when we drop them on a rough surface, each individual ball bearing bounces back at the angle it hit the surface, scattering them in all directions. If we could look at a mirror under a microscope, we wouldn't see fibers or rough areas. So we see ourselves in mirrors because photons are not scattered. We see the card because photons are reflected from it, but now the reflected photons are scattered, and this prevents us from seeing our image.